Okay, welcome guys. Here we are, we're gonna shred some trails here down at Moncton Borough's Pantera trail system. But first I want to talk to you about gear ratios and how we're gonna look at either getting our gears to help us climb or help us pick up some wicked good speed on the way downhill.
We're going to see how using different sized gears with different number of teeth is going to impact the number of revolutions. I'm going to start with my drive gear here is going to have 36 cogs on it. So if you start here at the white line and you count 36 times around, you'll get back to the white line. Now I'm going to put that here starting with the green arrow, and we'll call it 1 revolution to get the white line to go back to the green arrow. Now, I'm going to transfer that force onto a bigger gear here with more gears, one with 60 cogs here. So I'm going to line up these white lines as good as I can here, right? Now I'm going to have a 36 to 60 gear ratio. Got it? And let's type that right into my calculator here. 36 divided by 60, that's going to give us 0.6. 6/10 if we reduce that fraction. Now what's going to be cool about that is as this 36 cog gear goes around 1 revolution, the 60 cog gear is only going to go around 6/10 of a revolution. So let's see how that works. So I'm going to go all the way around 1 revolution. That sent that white arrow here 6/10 of the way down right to this line here. Let's darken up that so you can see how far that went, right? That went 6/10 of the way around that circle. Pretty cool, right? Now let's change that gear ratio and have the 36 transition down onto smaller gear. So I'm going to send 36 cogs here down onto 24 cogs here. And I'm still lining up my white lines. Now, now our gear ratio, it's not going to be 24/36, it's going to be 36/24. So when I type that into my calculator, 36 divided by 24, I get 1.5. So now this 1 revolution of my 36 cog is going to transition into 1.5 revolutions, so it's going to go all the way around and then around again. So just like we saw it before, I'll go up this time and then this will travel down. So, or I guess we should be talking about clockwise, counterclockwise, right? So I'm going to go counterclockwise to get this to go clockwise. Here we go. And we've gone around once and a half, right? Let's see that because that was so awesome. This way, I'm going to go around once and a half and get right back to where I started. That's rad. Okay, so let's take another look at our gear ratios here. We saw our 36/24 gear ratio produced 1.5 revolutions on this smaller cog, right? Wonderful. Now, remember, in physics, we don't get something for nothing. So the work has got to stay the same on both gears here. So my increase in revolutions over here is going to mean decrease in power, right? So I will make this 1 revolution, well, let's just say 1 unit of force. I'm going to get 1.5 revolutions over here. It's only going to give me 0.75 units of force, let's say. Now, that doesn't sound great, right? Because we're actually losing force on this back wheel. But remember, on this cog over here, set up with this gear ratio, where I'm losing revolutions, right? I'm only getting 6/10 of the way around. But if I'm only going 6/10 of the way around, I'm going to be gaining that back in force. So I'm going to turn this revolution into a greater amount of force over here. That's going to help me climb up my hill.
Now, with the big gear in the back and the small gear up front, I'm going to be able to climb up this wicked big rock. Check it out. watch me climb this.
Back over here, where I'm losing force, but gaining revolutions, might be gaining distance, that's going to help me pick up speed on the downhill, so my smaller force is going to go to bigger revolutions here.
With my smaller gear in the back, it allowed me to pick up some crucial speed on my way downhill.